Now, 20 years ago, if you wanted to win a Formula One race, you had to get a good car and a good driver. And if the two were good enough, then you'll win the race. Now, today, if you want to win a Formula One race, you actually need something like this. Something like this, it's a system that's made of thousands and thousands of sensors onto the car. Those sensors collect information in real time. That information is sent to this computer, analyzed, processed, and then decisions are made in real time. Like in this case, that was at the entrance of the World Expo 2008 in Zaragoza in Spain. And the idea at the beginning was, imagine you have a pipe, and in that pipe that you see there, you got solenoid valves opening and closing very fast based on a computer input. And if you do that, then you can have like pixels made of water. What you can see here, you can write on it, you can show images, text, patterns. If you approach the wall, you can it will open up to let you through. So it becomes almost like a living wall, a living material. Because of that, we got a commission to design the building. That was the initial renderings. The whole building is made of water. And then if there's too much wind, you can lower the roof. Or at the end of the day, you can actually close the building. And the architecture disappears.
Thanks, Carlo. Well, going back to sensing and actuating. Now, this is part of a project we're doing in Singapore. It's a big project called Future Mobility that we share with several other teams at MIT. Our part of it is called Live Singapore. And the focus of this is to really look at all these networks that service our cities, from cell phones to mobility. We partner there with our biggest cell phone service provider that gives us information in real time, with the port, with the airport, the Land Transport Authority. They have sensors under the ground. There's a smart grid experiment in the southwest. All this information comes into a platform, an open platform, where it's being combined, and then we extract new knowledge about mobility in the city so that we can actually make the city move more seamlessly, so that we can allow people to traverse the city faster, in a more environmental friendly way.
But if we go back to the sensing and actuation, go back to the Formula One example, what you want to do in the end is win the race. What you want to do is actuate, is respond to all this information.